Hi. We are going to try to do a bit of modeling for recurrent neural network, and we're going to start with something easy. I mean, both of them are quite easy. And what we are doing here, basically, with the first problem, we are going to uh, use an RNN to predict MNIST. And MNIST is a large database of handwritten digits that is commonly used for training various image processing scenarios or systems. And since this is a simple data set already in sequence, we can understand what model wants from us relatively easily. And so let's start doing that. Uh, what I'm going, and by the way, this MNIST is part of the Keras dataset, so you can load it from there, no problem. So I'm going to get sequential dropout LSTM, and I'm going to use LSTM as a recurrent neural network, and I'm going to load the dataset. And our layers are also going to have dropouts as well. So we now are going to load the data, and we can see the shape again of the data set for individual samples. So this is some error, I just renamed the thing. Okay, and then I'm going to build a model, sequential model. I add LSTM layer, then I add dropout layer, LSTM layer, dropout layer, fully connected layer, and a couple of them. So let's see how that works. And I'm going to get a Keras optimizer. From Crest, I'm going to get Adam. So this is my optimizer that I'm going to get, and then I'm going to simply train the model. And this is going to be quick. I'm going to have only 3 epochs here. Of course, in reality, you don't do it like this. Basically, with 3 epochs and the whole dataset at the same time, but let's see how this runs. I probably stop the video here and I get back again. It's fast, but potentially not that fast. So I see you after the training is done. Okay, as you see now my training is finished, and it ended with a very good accuracy, like 98%. You can give it a try yourself. It is a pretty well behaved data set. Uh, before ending this hands-on practice, I wanted to show you something that is not image. So far we only worked on the images, but as I said, these methods could be used on other sorts of data as well. And this is another simple example, but it gives you an idea. And it is a time series data. The problem here is that, given a year and months, we want to predict a number of international airline passengers. And we have the data set that I will upload into GitHub so you can give it a try. So let's load import the libraries we want, and let's have a look at the data set. Okay, so you can see the upward trend in the data set over time, and you can see some sort of periodicity as well. Now let's try building our model. I'm going to import the needed libraries and then loading the dataset. I'm also going to normalize the data and then split the data into training and test dataset. Okay, and what I'm going to do next, and this is something important. We want to create a new dataset, and the function that I'm defining here takes 2 arguments: the dataset, which is a NumPy array, and then we want to convert to what is useful for this problem, and the look back, which is the number of previous stamps that is used as input variable to predict the next time period. And in this case, we put it as 1. And basically, it creates a data set where x is the number of passengers at given time t, and y is the number of passengers at next time, which is t plus 1. It can be configured, and we will do that by constructing a differently shaped data set. So let me do that and then reshape the data set. And then reshape the input into sample timestamp features. This is how LSTM expect your data set to be. Very good. And then I'm going to make a very simple LSTM network and fit the model. This one I promise you is very fast, so I don't pause the video. And you see the loss is getting smaller and smaller. And once the model is fit, then we can estimate the performance of our model. Now what we do here is to make some sort of predictions and see how the model has performed. Okay, and this is a fairly good score. You can have a look at the dataset and you can decide on that yourself. And then let's see how our prediction looks like. And as you see, it did a decent job. So it is how we're using recurrent neural networks, LSTM in this case, for predicting time series data. And that's it for this hands-on practice. See you in next video.